Good, we'll share the screen. Good. I'm 15 right now, and we're still wrapping up the very, very last section, which is, it's chapter 7, but remember we're only doing 2 sections there, so we'll just call this the measurements. Continue. 2 examples. Remember, for example 1, if I give you something in the Imperial System, aka the stuff they use in the US, right? You need to be able to convert it back and forth in terms of same system. So our system is again Imperial, if no one remembers that, and can reference that in our previous lecture. If anyone was curious why it's called Imperial, it resembles from the Imperial not dynasty, but imperial order that the British rule, or the imperial rule of basically England conquering, or the British conquering everywhere. So that's that. And then all of a sudden they converted to metric, and then the US stayed on imperial, but everyone else went with the British system, which was kind of weird. So just remember, if you get something like, oh, let's do something easy like convert. Let's say 1,000 seconds to days, right? So this one's a little bit tougher because you can see it's a large stretch, right? You're going from seconds to days, right? And everyone knows the time, right? In terms of how many things are in an hour, how many things are in a minute, and all that fun stuff, right? And that's not the hard part. The hard part is just remembering to go through each step so that you could not miss any conversion points, right? So remember, a good hint is to realize where you start and you write that down immediately. And then you put that over 1 to help you visualize the fractions, and you know that every fraction is always multiplying. So then you're trying to get it from seconds to days. So start with what you know, right? I know that, let's use green here, that if I want to get rid of seconds, it makes sense to go next to is what? What's the next time denomination after seconds?
Minutes.
Minutes, right? So then how do you know like which numbers to use, right? Well, 60 seconds is a minute. You already know that, but again, how do you know that you're supposed to put the minute on top of the 60 seconds on the bottom? Remember, we're trying to cancel out these units right here. That's how you know, okay? And whenever you're trying to get to the bigger unit, you know that it's always going to be, let's not use purple. It's always going to be generally the smaller. That's not always a promise, but you can tell. So you just seconds, you're now looking at your minutes. And then the next is hours. So again, you get 1 hour, 60 minutes. And then you get the same type of cancellation here. I'm gonna do it. I know it's color code here, but I'll do a double slash so people can see. And last but not least, if you're trying to get rid of hours to get to days, in 1 day, there are 24 hours. And then last but not least, you can see the cancellation here. 1, 2, 3, 1, 2, 3. So the point of the units, again, they're supposed to guide you so you keep track of what to cancel. And the numbers, it just becomes one big fraction, right? So let's use gray here. I know gray is not a color I use often, but you can see you're going to go 1,000 times 1 times 1 times 1, right? That's the numerator, 1,000. And then the denominator, you can see that it's 1 times 60 times 60 times 24. Now you have to do that. Get a calculator out. 60 times 60 times 24. 8,600, 400. Now you could use this as, you can leave it as a fraction, but of course you have to always simplify it, right? But I wouldn't even do that. I would just divide this out, right? Because you know it's going to be a small number divided by 86,400, right? So then this is going to approximate 0.0157 days. Now, how did I know to go 4 decimal places out? I didn't. Just found out enough numbers so that people can see that they got the answer correct. So nothing special in particular. However, notice how the numbers don't cancel evenly, right? 1,000 and 8,000, 86,400. It doesn't go into it evenly and everything of that nature. But the important thing is notice how it wasn't we didn't use a single conversion fraction. We did not use a single conversion fraction. We used 3 different ones. And what were the 3, right? They were here, 2, and 3. And again, remember these are unit or conversion. Right? They guide us to get to the unit that we want. So you can see sometimes a class, one example, and it's easy because they have one unit fraction, boom, you're done, right? And then sometimes it'll be long strings like this, and then it's not, again, hard, it's just that you got to remember, oh, what comes next, right? Now, what if we have a metric system like we did last week, right? Say you had something, they said, hey, I want you to go from, oh, I don't know, let's do grams this time, right? We're going to go, what's today's date? 26, yeah. We'll go 20 grams. Sorry, I forgot the word convert. 26, let's say, oh, I don't know, hectograms. Hectograms to milligrams. So again, let's write this here. Remember, this is imperial here. And this is metric here, metric. But the thing is that you can use, I'm going to scroll up just a touch, just in case people need to see that fraction. Remember, you can use the whole King Henry died. Someone typed in the chat, I forgot who it was, but I definitely want to shout out them and give them credit, that for the unit, right, that counts as a space. So King Henry died unusually drinking chocolate martinis. So remember, this is the order, and you can remember that this is kilo, hecto, hecta, unit, deci, centi, and milli. And those are all prefixes. They go in front of the word that you're talking about. So how do you do this again, right? Well, you find where you start. So that's right here, 26 hectograms. And you want to go to milligrams. So you want to be able to move, and this is why that unit portion in the middle is important, because it counts as a space, right? You have to move one, not 2, not 3, not 4, but 5 decimal places. And you might ask, well, what the hell is a decimal place you're talking about? It's like, well, the invisible decimal place, that's right here, right? 26. So you got to move, what is that? 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. And then you'll have, place your commas, right? This is equal to 2, 6, 0, 0. Yes. All right, so again, the easiest way to go about for the metric system is memorizing this mnemonic device to remember King Henry died unusually drinking chocolate milk, chocolate martinis, whatever the case might be, right? And then what happens is that you use that every time and you remember, just go the direction that you see written in this order, and you'll be able to get it right every time, right? I may have not said it in this lecture on Wednesday, but a clue you can always do is that you can notice that when you're looking at these problems, right? If you notice that if you move from left to right with the prefixes, they decrease, but the number increases. So again, I'll write that really quick here. Note, prefixes increase. Actually, I should write it this way. Prefixes decrease with right. So, numeric value increases. So remember, in numeric value is strictly describing the number. You see how we went from T6 to 2,600,000, right? It's not a different amount of grams. It's just a, oh gosh, how do you say? A conversion of the same amount of information. Again, a conversion of the same amount of information. And then you can say the same thing as well. Prefixes, let's write it in blue or navy. Prefixes increase going which way? Not right, but going left. Numeric value decreases. If you never notice that pattern, again, you don't have to write this down. And I wrote it in the other lecture, my other section that's after your guys's. But it's helpful. It's like a quick check without having to do all the work. Though to be fair, it's not a lot of work to begin with. Now remember, you have to be able to convert from any imperial to imperial and any metric to any other metric, which is easy as you can see. Now, example 3, this is what I was telling you will be on the final. However, you can't do it unless we provide information. And the good news is that the information will always be provided. You just have to recognize it. So, for example, let's see this. We'll go example 3. And I'm going to pull this one from the textbook. In fact, I'm going to screenshot what I'm talking about. IT. Look, and then what happens if I go to chapter 7? That's not it. Oh, this looks like chapter. Yeah, here we go. If you go to chapter 7, you'll see a table like this. Now, there's tons of tables. However, the table itself is not that important. It's just to recognize it. So let me just decrease the size of this so that you guys can see. I'm going to put this in ability to our current lecture. Done. Delete this. So you can see, here's this chart. And I'm going to increase it just a touch. And then now I'm going to do something just really simple right now, at least for the first time around, so you can see what's going on. So I'm going to say something, let's say, I'm going to copy this from the textbook. So we're going to say 500 liters of water in fluid ounces. So we want you to convert this. Now, this table, you do not need to memorize. Do not need to memorize. That is a given. And I can tell you that no one ever has to memorize it. And kudos to you, but you really shouldn't, nor should you really waste the energy and effort to. And I'll tell you why. The reason is that these details, they'll always give it to you. So that's why they say it's so important, like, oh, you must memorize the conversions within the same system. But when you go between systems, they're going to give you some kind of conversion. So even though our example says this, on the test, you might see it say something like this. Convert 500 milliliters to fluid ounces, where 1 fluid ounce is equal to 30 milliliters. So you won't even write it out in terms of a whole story and something to talk about and whatever the case might be, right? It might be very straightforward, but you can see that they provide the conversion right there. So you don't have to memorize it. You just have to recognize when you're going from one to the other. And then it actually ends up being the same exact thing, right? You start with what you know. You know this. You're trying to get this. So 500 milliliters. And then again, put it over 1 because that helps. Now, what is the unit of, let's use light blue, the unit of conversion between fluid ounces and milliliters? It's right here, right? Luckily, this is one where not only do they tell you and it's, I don't want to say obvious, but I want to say they tell you and it should be very apparent what you're going to do. So if you want fluid ounces, go on top, because it has to be the remaining unit, and then the bottom is, of course, the 30 milliliters. And you can see these cancel, and then you end up with over 30 milliliters, right? You do the math on that. You have 16.6 repeating milliliters. But if you were given a multiple choice test, right, they'll probably ask you to round to a certain point. So then if I say like round, say hundreds, oops. Now 200s. So then you can go 16.67. Oh wait, there's a typo here. It's not milliliters. That's what we cancel. It should be fluid ounces. Glad everyone was paying attention. Yeah, it should be fluid ounces. Nope, that's not your spot. Okay. Not incredibly intimidating. It's actually easy in the sense that as long as you know how to convert with the unit fractions and then use the units that are given to you, you're actually pretty much okay. You do it right, right? And then let me refer back to the textbook to see if there's any harder examples. No, actually, no, that's pretty good, actually. Yeah, that's fine. Because any other example will look just like this. And the last thing that you have to worry about is the formula for converting temperature from Celsius and Fahrenheit. Now those formulas you just have to simply memorize. So I'll just write them down for you. Again, they're in the textbook. But let me see. Actually, you know what? I'll copy and paste it since they're in the same section. So do a screenshot. And oops. Nope, that's wrong. Undo. There you go. That's good. Add it to our lecture as well. Delete. All right, let's make this a little bit bigger. So the problem, hey, I want to change so many Celsius to Fahrenheit, or I want to change so much Fahrenheit to Celsius. You just use this formula. That's all it is. Right, I'm gonna scroll up now. You use this formula and you use the algebra needed, and it's pretty much it, right? Let me make sure there's no other sections here. Yeah, this is the last one. So let me just show you a really quick example here. This is example 4 now. So say you had, let's say Fahrenheit equals, what's today's temperature actually? Oh wait, I'm in Celsius, so never mind. Let's say today is 40 degrees Fahrenheit. All right. And then what happens is that you go, okay, if I'm trying to go to Fahrenheit, or they give me Fahrenheit, that means you must be going to Celsius, right? To Celsius, Fahrenheit. So then you have the formula, as I suggest. You just write the formula down. Maximize your learning potential. Minus 32. You plug this in right here. So then use your calculator, right? You go 5 over 9 parentheses, leaves 40. Oops. 40 minus 32. 40 minus 32. Yep, that's good. And you just calculate it out, right? Just remember that you have to subtract 40 minus 32, or subtract 32 from 40, however you want to think of it, before you multiply by 5 divided by 9. So you should actually get 4.4 P Celsius. So almost freezing, right? Celsius is freezing when it's there's below 0, or even at 0 for some. Yeah, that should be fine. Yeah, that's fine. And then if you do it the other way around, say we want to look at today's lecture, sorry, not lecture, today's temperature, right? So I can actually look at it on my watch. So I'll grab today's temperature, which is where can I find this right now? Oh, is it directly? So I'll just Siri to say it. Hey Siri, what says weather?
It's currently foggy and 12 degrees.
So 12 degrees today, 12 degrees Celsius. And then you want to convert to Fahrenheit. And then you just reuse a formula. The formulas, they look very similar because they're just a switching of the variables. So they kind of flip-flop, if you will, but it's not the same exact formula, just similar format. And the reason is, again, they're taking each other's places. So then you rewrite the formula. Let's do this one in light blue. That equals 9 over 5 E plus 32. So you can see here that this C is right here. Notice how there's not parentheses this time either. So then you continue, and you got 9. No, let's use a different color. 9 over 5, and now you know it's C, which is 12, or plus the 2. So in this case, 9 times 12 is 108. That one I do remember. But divided by 5 plus 32. And then for those that were curious, today's weather is 53.6 degrees Fahrenheit. Right? So the last part here with the whole degrees and everything, that's not particularly special or unique in terms of algebra because you've been doing it, you've seen it before, you're familiar with it. And what happens is that it's just in case that one of these show up on the final and you want to be ready for it. If I recall correctly, they do not give you the formula, so you just want to be able to memorize these two right here. I'll just put little purple boxes around them because that's normally what I do for formula, like that. Okay, so I'll leave that there for a brief moment. What questions do we have so far? I don't expect a lot, to be honest. And this is actually the end of the section in chapter 7, right? I know that I spaced it out in terms of talking about the conversion for the imperial and then taking the time to do metric. And the thing is that metric is really easy. It's just grasping the whole King Henry thing, right? The mnemonic device showing that how it goes from kilo, hecto, deca, the unit, and then the deci. No, wait, I'm saying something wrong. Deci. Oh, that's right. Deci, centi, and then milli, and then you can just go from there. That's good. Okay. What questions do we have here, if any? Dead silence.
No questions.
Yeah. Okay. No questions. Okay. I got all excited. I was like, all right, I got a question. No. Okay. Sorry, that was my fault. You guys still participate more than my other class, so just a heads up. I love you guys for that, you know. Maybe not in a romantic way, but I wholeheartedly appreciate it. So hearing just from you guys, even if everyone's not having their cameras on. But to be fair, today I don't have my camera on, so today doesn't count. So I'm not talking about today in particular, but just having you all participate, it's really good, you know, because we're in a pandemic and all that fun stuff. So I love all my classes, love more when they participate because it's really helpful. It shows me understanding, it shows me what I can do to improve. So keep it up. And that goes double for my other class too, because you're going to hear this and you're going to think, oh, you're just favoritism with it. It's like, no, just got to participate more. Okay, if you look at our OpenStax section or book section, it's that same PDF I always refer to. The algebra section now. So we're done. This is all done. This is what your first midterm is going to be on. Am I going to ask every single problem of this? No, there's not enough time. And you'll have time to do it because, like I said, it'll be given to you to work on for a week, and you'll be aces. You'll do well. I imagine everyone will do well because they'll take the time to do it. They won't rush it. Don't do it last minute, right? However, if you notice chapter 2 right here, it says solve equations using the subtraction and addition properties of equality. Well, we kind of almost did that already when we solve equations, right? And then if you look at 2.2, solve equations using division and multiplication properties of equality. Well, we kind of did that already too, believe it or not. And then solve equations with the variables and constants on both sides. We almost did that. Use a general strategy to solve linear equations. We can talk about that. Solve equations with fractions or decimals. Oh, wait, we did that. But the new thing, per se, quote unquote, is a solve formula for a specific variable. So I'm going to, gosh, how should I do this? I'm going to do maybe, I don't want to make a question too ugly. So you know what, let's do this. I'm just kind of meshed in together, right? The multiplication, the division, and everything. And you've seen something like that already, right? I just didn't go ham crazy with it because I didn't want to freak anyone out. But now, a textbook, if you will, where you're gonna have to see it anyway. And again, like I said, I'm giving you harder examples, but the final won't be anywhere crazy like that. Okay. So let's do our 2 examples, and then we'll call it a day. Okay, so we're now in the text. And then we're in chapter 2. And again, chapter 2 technically is just a review because we've been working with the algebra so long, right? So it's kind of like a review. Words, a review. Let me speak in complete sentences. A review of solving. And remember, all these problems will say solve because there is an actual equal sign. So this is example 6 now. So let's say you have something nasty. Let's say I have something like, oh gosh, you know what? I won't throw the crazy multiplication. Well, no, I won't do it just yet. I will save that for Wednesday. Okay, so let's say we have something like this. 1/2 x times 40 minus 10 over x plus 5 equals 3 times negative x plus 2. All right, say we have something like this. Again, you're not going to see anything like this on the final. I'm just being really mean right now. Okay, let's take a moment to write that down. I'll give you like about 30 seconds or so. You want to have a good weekend? Do anything particularly interesting?
I had a pretty good weekend.
Okay. Do you mind sharing?
You
You don't have to.
Well, I kind of forgot because.
Oh, because you drank too much.
No, I didn't do that.
No, of course not.
No, just you know how it is. I think we decorated for Halloween.
Oh, that's right. Yeah, I imagine.
Yeah.
Are people going out for Halloween? It's kind of weird because we're
I don't
mid-pandemic
know.
still.
I don't think so, but just for fun, we decorated.
Yeah, definitely. That does sound nice. But of course, the crazy thing is, I mean, I don't know how it is on the East Coast because, especially here, in the boroughs and everyone is like in apartments, and the moment Halloween's over, all the Thanksgiving decorations go up, and it's pretty crazy.
Yeah, crazy.
All right.
How was your weekend?
Oh, I just worked, but thank you for asking. It's really difficult because when I'm working overnight, I have to catch up on sleep, but then I also have to do work for you guys as well. So all three of my classes, they're kind of just, I'm on top of replying to everyone's emails, as I'm pretty sure everyone knows, but then just drilling out the work that I had to give you guys. It's kind of like, I had to do it in a nice way where it makes sense. There's not typos and things like that. But thank you for asking either way.
No problem. You should give yourself a break.
I don't know. You guys all depend on me, so gotta be on top of it. All right, let's scroll up just a touch. Okay, so like I said, this looks evil, but when you look at it, a lot of it simplifies, and you actually find out that it's taking a lot of ideas that we have. So what do we have? We have some distributive property here. We got some multiplication, right? It looks like we have division too, but if you look very closely, so I'm going to do this distributive property with purple, and then this one on the right of the side of the equal sign with blue. Well, I always say do what's easy first, right? So blue, we got a negative 3x plus 6. So that's from this. Always drop down the things that don't change. So your equal sign here and 5 here. And again, this is exactly how I learned it when I was learning algebra / pre-algebra for the first time. As per usual, if people have a better method or they do something that goes, hey, well, professor, I always do it this way, and it tends to work out all the time, hey, lay it on me. It might help not only yourself to teach me something new, but your classmates might really appreciate it. Okay, what about this one right here? Well, if you do the first distribution, you're kind of going, oh crap, there's a fraction, but it's a half. Well, what's half of 40? It's 20, but there's an x there. So 20x. Then you go to the next one. You're like, damn, I got half x, and then now I got this x in the numerator, or denominator in this case. But wait a second. Remember, let me use a different color. This x right here, because it's next to the fraction, that's technically x over 1, right? Or another way to think of this, I'm going to draw a bigger circle now and just think of this x over 2. So you're actually multiplying x over 2 times 10 over x, technically a negative 10 over x. So this actually will simplify to just a minus 5. Why is that? Again, not to bore too many people, remember you're doing x over 2 times, I'll draw it in black so color coordinates. This, so that's the second distributive portion there. So you can see the blue arrows matching the light blue fractions here. You can see the x's cancel and you get negative 10 over 2. And then at this point, it's a regular algebra equation that you can all do. So let me use a dark green. Now this, you just want to be clean about it. What I mean by clean is you want to be in terms of how you attack the problem because you don't want to make any silly mistakes. You don't want to add extra numbers to either side of the equal sign. So what's a strategy, if you will? I remember when I was learning this is that you combine everything you can on left or right. So don't move anything yet, just get it super simplified. For example, this is a happy mistake because I didn't plan this. These two, what happens to them? They, another question. What's a negative 5 plus 5?
They cancel.
They cancel, right? So then that means you're left with a 0 here. Don't have to write 0, but you're left with just 20x on the left side. Can't do anything else there, so that's done. On the right side, you notice that you can't combine these guys. And make sure I didn't make any typos. Negative 3x. Yep.
How did you get negative 5? Sorry.
No, that's okay. Negative 5 came from this fraction. That multiplication of two fractions, I'm sorry.
Okay, thank you.
Yep, no worries. And then just in case if anyone missed it, remember those two fractions. The negative 10 over x is obviously the black one, but the green x over 2 is just a simplified version to write x. So just a little reminder there. At this point, then you just, do your thing, right? Plus 3x plus 3x. Yeah, cancel here. 23x equals 6. Divide both sides by, let's use green again, 23. 23 is prime, so you know that this doesn't cancel anymore. So this implies x is equal to 6 over 23. And as always, like I always say, what's the way you can check your answer? You can
I'll get back in.
plug the answer back into both x's and see, well, actually this would be 3x's in this case, and then you can check your answer. But I would go even further by saying you don't have to plug it into the original here because then that's super messy. I would say if you distribute it correctly, you can actually put it in here and it will work as well. But in this case, since I made up the problem and I was careful, I know that this is a correct answer, right? So again, this is probably what I will show for like a homework, maybe a quiz or something like that. Remember, this is chapter 2 on the algebra textbook. This is what do you call your exam? If there is, it's going to be super baby version of this, not super complicated like this because it combines everything that we're doing. Okay, let's do one more and then we'll call it the day. So example 6, that's good. Let me think of an example that would be good. Okay, I won't make it too crazy, but I want people to get familiar with this. So let's do it this way. Let me think. Here we go. Say I got. Sorry, that's me thinking right now. Let's say we have 3k minus, let's say 4 squared. This is going to be equal to 2. I'm thinking. Let's say 5. Yeah, looks good. Actually, no. Let's go +1. Yeah, there you go. Yeah, that's good. Now, there are 2 strategies for this, though. Anyone can think of one of the strategies? Anyone have a suggestion? Because hopefully people recognize that the crappy thing is that you got, let me underline this here. You got a variable here and you got a variable here, but it's not simple because you got the 3k, which is simple, but you got that 2/5 k or 2k over 5, 2/5 k, that's in a fraction, and that's not simple. So there's 2 ways to get rid of this. Anyone remember? It's okay if not.
Would you make the 3/1? Okay, or no?
3 over 1k. So you can, and then what you do, right? You can combine them like fractions and then call it the day, right? That's what I was guessing. So that's a great idea. So you know what? There are 2 strategies, and I'll put here in parentheses, possibly others. 1 to 2 strategies. So I don't want to discount anyone's participation, of course. So we could three k to 3k over 1. And if we do a common denominator, then that would mean this implies that you would do a common denominator of 5. So it'd be 15k over 5. Hopefully everyone sees how I got that right. We were told to, or we were suggested to put it over 1. And then if you're going to combine, you can do times 5. Oops, sorry. Times 5. And so that's cool because the denominators are easy. You can combine them. The only thing though is that this makes it harder, right? It doesn't simplify. And that's the beauty. And I know that it sounds very lame to say, hey, the beauty of algebra, the beauty of mathematics, you know, I get that. But I'm going to say it anyway because that's what makes it very fluid, how I guess I could say, because mathematicians, and I've said this before, they're lazy, right? I'm lazy. I'm lazy as a person and a mathematician. And what you want to do is you want to just knock out the hardest thing first. So we could do this. It's just that it seems that we're going to do extra work for something that's harder. Okay? It's not wrong though. So great idea. Anyone else remember? I'm gonna scroll up just more. Anybody remember any other strategies that they may have learned or kind of recall, not really? Hard to say. My hint to you is, has anybody heard of the phrase clear all fractions, maybe? Maybe that's an old school thing. All right, so let me show you what I think is the easier one to understand. So I'm gonna do this in navy. No, I'm gonna do it in green, the dark green here. So the first strategy, I would say you want to get you know what, I lie. There's only one strategy I want to show you in this particular case. And it is that whole clear all fractions. Oops, clear. C-L-E-A-R, clear all fractions. So can we all agree at least, what is the one number that if we multiply, we'll get rid of the fraction? So hopefully everyone sees that the only fraction is the 2k over 5, right? Let me draw that nicer. Right, everyone agrees that's the only fraction. What is the magic number that you can multiply this that no longer makes it a fraction? How can you cancel the denominator? Come on, I know you guys know this.
Is it divide?
It's 5, right? Wait, you said 5 or divide?
I said divide.
If you divide, you can divide by 2, and that'll get rid of the 2 in the numerator, but I'm talking about just the denominator. I guess I kind of give it away. It's 5, right? So if you multiply 2k over 5 times 5, you get just 2k. Does everyone see that? If I took the time to, let's use purple. If I multiply just this fraction by 5, or 5 over 1, if you really want to be specific, does everyone see 2k simplifying to itself, right? Or I guess the better question is, who doesn't see that? Who doesn't understand that? That if I said, hey, if I look at just the fraction alone, 2k over 5, and I multiply it by 5, I'm sorry?
This is
You don't see
Debbie
it?
speaking. I
So
don't know.
that's okay. So let's pull this to the side, just right here. Do you see it if I write it like this now? Yes or no?
I see
It's
it.
okay if you say no.
No, I see it
Okay.
now.
You see it now? Okay. If you didn't
Yeah.
see it, not you, Devaney, but anyone for that matter didn't see it, remember you can always take it one step further by doing this. 5 times 2k over 1 times 5. And hopefully now you can see that, oh, right, that 1 is nothing. Actually, let me do that in a different color. That 1 is nothing. These guys cancel, and you're left with 2k. All right? So anyone else who doesn't see the light blue bracket that I have arrow pointing to the right side there. Now this is, again, an easy example because we're going to get into harder examples so that I can help you a lot more. But again, we'll keep it simple right now. So here's the thing though, right? Think of equality, equations, EQ, right? EQ, equality, equations, and even with numbers when we're simplifying fractions and all that kind of fun stuff. Multiply one term. Remember, we have 4 terms here. These are all called terms. Algebraic terms. 1 there, 1 there, 1. Nope, not that purple one. 1 black, and then 1 there, and 1. So those are all terms, right? So if I take one term, in this case, the egg-shaped green, right there, and I multiply by 5, what do you think I have to do with all the other terms as well to keep equality? Say it one more time. If I multiply the fraction by 5, or 5/1 in this case, right? But if I want to keep my equation equal, what do you think I have to do with all the other 3 black terms? And we'll take a guess. What did I do here? This 5/1 is doing what to this egg, aka this 2k/5? Come on, I know you guys can answer this.
Ask the question again.
The question, the overall question is equality stands in equations because what you do on one side, you have to do to the other. So my initial question was, if I multiply 2k/5 by 5, or using colors, if I take the 2k/5 fraction in black and I multiply it by that purple 5, like I just introduced that purple 5, why 5? Because it cancels out my denominator. If I'm going to keep the equation equal, what do I have to do to all the other 3 terms?
The same thing.
The same exact thing, right? So this is actually a strategy that you've learned at one point or another. Whether a teacher has explained this well or not, that's a different story. But the thing is that we multiply by 5 because this is the only fraction, and the easiest thing to multiply by to get rid of the fraction is 5. Now, could you have multiplied by 10? Absolutely, because 10 divided by 5 is 2, right? It gives you a 2 in the numerator. But why use a bigger number when you don't have to? So the reason, again, we pick 5 is that 5 can cancel with the denominator that I drew with the purple arrow there. But since this is an equation, you can't just do it to one thing. You got to do it to every single guy here, or every single term here. So that's what I was trying to get to. So if you multiply by 5, you can't multiply by 5 to 1. You can't multiply by 5 to everyone. It's like kids, right? If you have 4 kids, you can't just give one kid $1. You got to give everybody $1. So in this case, if you have, you notice one kid, quote unquote, this 2k/5, right? This kid right here, I'll put in quotation marks, right? They're the most difficult because they have a fraction and they have a denominator of 5. It's like, well, what do? I got to give them $5. I got to multiply. I can't just do that alone to just this kid here. You got 3 other kids to worry about. So that's why they all get multiplied by 5. So then what that means is that then this gives, we're left with 5 times k, right? Minus 4 squared, which is 16 times 5, equals, doing a little bit of simplification on the way, simplifies to 2k, because the 5's disappeared, plus 1 times 5. Right? So hopefully people can see that a little bit clearer now. You can rewatch this video once WebEx, finishes processing the video. And yeah. So I'll finish this and then we'll call it a day. So let's use different colors so people can see. So 5 times 3k is 15k. 5 times 16 is negative 80. You're left with 2k and then plus 5. So now you can see nothing else simplifies on each side, and you can just solve it like a normal equation. I'm going to subtract the variable first because that's always easiest for me. These are canceling. This is 15k minus 80 equals 5. And then I'm going to add both sides. So you're going to have 85 now. 13k equals 85. And then divide both sides by 13. And you got k equal to 85 over 13. And that's the right answer, because I took time to simplify everything. Now, if I wanted to take the time and say, oh, how do you put this in a mixed number? You can divide, remember? You do long division, that's one way to do it, right? Or you can just, ask yourself, how many times can 13 fit into 85? Well, it is, I believe, 7 times 13. Nope, too much, 6 times 13. Yeah, so it's 6 times, and that's 78. So 85 minus 78 is 7. So then this is or k equal to 13 and 7 over, no, sorry, I wrote the wrong number. The whole number is 6. 13 fits into 85 6 times, and the remainder is the numerator over 13. So this is a little bit of practice in terms of the whole improper fraction to a mixed number, but both of these are correct though. All right. I would say if that didn't make the most sense, just give WebEx a while. Normally it takes about half an hour, right, to populate, and then you can rewatch this last question, because it does 2 things, right? It was the explanation of why we multiply everybody by 5, and then the second explanation of recalling how to change an improper to a mixed number. All right. What questions do we have here, if any? Okay, cool. So remember the conversion stuff, right? We did a quick review, imperial, metric. I showed you the conversion between the two, but remember, we don't need to memorize it. You just have to recognize that when the problem gives it to you, you know how to do it. The temperature conversion, not a ton of problems like that on the final, but just enough for you to be like, hey, pay attention. Those formulas won't be given to you, so definitely memorize them, right? And then we started algebra, and I gave you harder problems, but of course, we're gonna have more practice. So let me back this up so that it will save to Blackboard. And again, if anyone came in late, remember, I'm gonna be posting the midterm soon. Not today, but when I post it, it'll be in the announcement section in Blackboard, sent to the entire class. And what will happen is that you will, I can stop recording right now. Actually, no, I should finish talking. You'll be emailed, because this is going to apply to both classes. You'll be emailed and posted on the announcement section. It's going to be an open-ended exam, so it's not multiple choice. However, in the coming weeks, I'm going to get on the regular to do more quizzes so that people can get used to doing multiple choice questions. And they're not going to be long quizzes. I promise you that. I definitely can promise. They're going to be like, what, 5 questions? You have 24 hours to do them once I post them. Easy peasy, Obviously, you want to try it on your own, but I'm not going to stop you if you're going to make it open book, open note type of thing like that. But the more you practice on your own, the better. I got a couple of chats here. Take break like Eliza Hamilton says. Is that from the musical?
Yes, it is.
Okay, see, I haven't seen it yet. So,
Dude.
yeah, I know. Yeah, I know. I've been living here forever, and it's like I haven't seen it. But I don't want to pay the expensive ticket. I'm gonna stop recording now. Stop recording.
Just watch it on Disney Plus if you have it.